Perhaps one of the most important application of counters is timers. Actually, whenever you encounter a timer in the digital system, chances are it's built using a counter. So in this video, I'll show you how to use modulus counters as timers. But before I get into the details of the coding, I just want to explain to you what I mean by timers and counters. So what's a counter? Well, a counter is just a device that goes 0 all the way to a certain number. Basically, it counts between a couple of limits, one in here, and I'm going to say one in here. And for simplicity, I'll only consider counters that go up from 0 all the way to a certain value, and I'm just going to call it value. So it goes from 0 all the way to final value. You can do the same exact thing with downwards counters that go from certain value to a 1 or something like that. But for simplicity, we're just going to stick to 0 to the final value. Okay, so now let's assume that we have a counter that counts this way from a 0 to a final value. Okay, how long does it take it to go from this value all the way to here? How long does it take it to go from 0, 1, 2, 3? Like if I'm actually to time it and just say a timer that starts exactly at 0 and finishes exactly when I reach the final value, how long will it take? Well, it all depends on the clock frequency. So I'm going to give you an example in here. So the board we've been using contains a clock on it, onboard clock, that is actually 100 megahertz. And if you compute the period of that 100 megahertz, you're going to see that it's actually exactly 10 nanoseconds. So let's say that what I really have is I have a final value that is actually 255. So how long does it take for this particular counter to go from 0 all the way to 255? Well, each one of the counts will need a clock cycle. So each one of the counts will take exactly 10 nanoseconds. So for a 10 nanosecond period clock, and going from 0 to 255, I know that that's 256 counts because I'm counting 0 and I'm counting 255 all inclusive. That means I would need 256 times 10 nanosecond, which is exactly 2,560 nanoseconds to get that, or you can just convert it to millisecond or microsecond for that matter, okay, for 2.56 microsecond. Okay, so this particular counter that actually operates at this particular frequency that goes from 0 to 255, it'll take a 256 microseconds. So if I'm actually ticking something every time it actually finishes, it's actually a 2.56 microsecond ticker. Now let's flip it a little bit, because usually when we deal with counters, we don't deal with counts. We care really about the timer. So let's say in a real life situation, what you really want to do is you're designing some sort of a system, and that system actually has to go and last for, let's say I want it to last for 500 microseconds, okay? So what I'm really after is what should be the final value of that counter, so that I can use modulus counters or whatever counters that I need. That will actually last, if it counts from 0 to that number, final value, it will last for 500 microseconds. Really, the question I'm asking is how many 10 nanoseconds, because it's going 0, 1, 2, all the way to final values, and I need it to last for 500 microseconds. What I'm really asking for is how many, this is microsecond, how many 10 nanoseconds do I have within that 500 microseconds? And the answer is approximately 500, okay, times 10 to the power 3, okay, divided by 10. Like I'm converting it, like let's say, because I need to actually convert it to nanoseconds. So like in order, because I have like, let me just see, I have this is a nanosecond, this is a microsecond, so I need to actually convert it. So a 500 to actually go to the nanosecond, I need to multiply it by 1,000, so that becomes 0, 0, 0 divided by 10. Okay, and the answer is actually 50, okay, 0, 0, 0. This is actually 50,000. So I need a counter that goes for 50,000 counts. Okay, so a counter that goes between here to here for 50,000 count will last exactly for 500 microseconds. So the final value I'm after, kind of like what we did in here, this one counts for 256 because it goes from 0 to 255. The same thing, we need to create a counter that actually goes to 50, 0, 0, 0 minus 1, which is 49,999. Okay, and that's actually the counter we're after. So if we create a counter, a modulus counter that operates at this particular frequency and counts from 0 to 49,999, we'll get a timer that ticks every 500 microseconds. So in short, the timer is actually really reduced to using a modulus counters and figuring out what the final value of that modulus counter is. The counter we need to use is a 50,000 modulo 50,000 counter, but of course it counts from 0 all the way to 4,999. So let's see how we can implement this in Vivado. So I went ahead and I created a module. I called it timer parameter, okay, and I created that parameter would be the final value. And it might seem familiar because it really is the modulus counter itself. So it's actually final value as a parameter, and I'm just using the parameterized version. So this timer would be like once you create it, it's actually set to that particular time only, or that particular duration only. It will only count for a very specific duration. So frankly speaking, all I have to do is just really copy and paste that particular code in here. We're going to change it a little bit. That's why we're not instantiating the modulus counter. I can definitely use the modulus counter itself and modify it a little bit, but I think if I modify the code a little bit, it'll be fine too. So the timer parameter in here is basically the modulus counter. So it's modulus counter that counts all the way to a final value. However, the little changes that I want to make is the following. Frankly speaking, we really do not care if we're using a counter as a timer. Most of the time we don't care about the count itself that is it counting through. Okay, like sometimes we do, but most of the time we don't. What we really care about is actually that done signal. That is what I'm gonna call a ticker. It's actually whenever it's done, it's just gonna tick for a very short period of time, which is a clock cycle. So for a very specific period of time, that done will be ticking. So all I have to do is just now output it to the outside world. Okay, kind of like what we did with the BCD counter. So I'm just going to output it to the outside world. So what else do I need to do? Well, since I'm not using that, I can just expose the whole thing here, and technically I am done. This is how a timer is actually built. So a timer is just built by a modulus counter, but that modulus counter, frankly speaking, we don't care about the content of the counter itself. We just care whenever it finishes, and it should finish at regular intervals. So I created a test bench in here. So let's see the output of this test bench. So here's the result coming out of the test bench. So in this test bench, what I've done is I have actually started with, let's see. Well, I started with 4,999. This is actually the 500 microsecond ticker, the one that we saw in here. So we decided this is the 4,999. Actually, within the test bench, what I did is I created an instance of that timer. Okay, and I just gave it that the final value should be that. So I'm expecting it to tick every 500 microseconds. Let's see if that's actually happening. So I'm going to take a look outside in here, and you can see the final value actually in the bits and the t, they're all parameter. What I'm really after is actually that ticker in here. And you kind of see that these little tiny blips in here. So these blips are actually where my timer is telling me like, hey, 500 microsecond has passed, 500 microsecond has passed, and so forth. Of course, if you can actually take a look at the other signals, like I'm making sure that at the very beginning, like you can zoom in, I can really zoom in here to show you what's happening. I'm just resetting it for a certain period of time and then enabling it. And then after the enable, the timer is running. Okay, and that's how it's running. This is the clock. And of course, I'm showing you a lot of cycles in here, but what I really care about is to see and verify that this timer is actually doing exactly what I'm supposed to. So what I'm going to do is I'm going to stop at this done in here, and then actually I can play around with these little guys in here. So this one here, it's showing me this is the very first one. I'm going to move in here, okay, and it will move. Let me just zoom and show you what happened. So here and here, okay. So I zoomed in here, I'm stopped at the done. When I clicked on that, it actually went to the next time, it actually changed its value. So what I'm going to do is I'm going to create a marker in here. I'm going to just add that marker in blue. Okay, and then I'm going to go to the next levels just so that you see this is the next transition. So I'm expecting it to transition and stop here. So it did. And now what I really am after is actually a next transition, which is actually when is the next ticker. So I'm just going to add a marker in here. And of course, I can see if there's another change and there's another change. There's nothing else at that point. So I'm going to zoom out and I'm going to see that I have a couple of tickers in here. And I can see the difference between them to see if it's actually ticking every 500 microsecond. Frankly speaking, if you stop at this little guy in here, it will actually show you that from here to here, it's actually 500 microsecond. And to the yellow one, it's actually 99999. But what matters is the following. It's actually exactly 500 microsecond, exactly as I expected it. So what I have just done is I built what I usually call a ticker or a time ticker, okay, that ticks. I don't care about the number inside it. It just ticks for one clock cycle, complete one clock cycle. You see from the active edge of the clock here to the active edge of the clock here. And it does it every 500 microsecond because I've used that test bench with 4,999. Now let's see that case when it was 255, okay? So I'm expecting to see 2.56 microseconds. So let's see if that's actually the case, is the case. So this is after I have changed it to 255. Let's see, I'm gonna stop at the done. I'm gonna do this here. I'm gonna go in here. I'm gonna create a marker. I'm gonna do one transition, second transition. I'm gonna create a marker. I'm gonna stop at this particular marker, and it gave me exactly 2.56 microsecond, exactly how much I calculated it to be. Just in case you couldn't see it because it was behind this particular diagram in here, the number and where I'm reading it from. So after you add the two markers in here, the blue one, you can just stop at one of them and it will actually, like I'm going to stop in here and I'll show you how far it is from the yellow marker and how far it is from the blue marker in here. And you can see this is 2.56. You can also stop at any marker. For example, if you stop at this particular marker, I believe this one here, it will tell you, well, this is negative 2.56 and this is negative 1.2. And you can change that yellow one wherever you want. And you can see it actually showing you in relation to this particular marker that I selected, how far it is. And before I move on to the next slide or the next actual idea, what I want to mention is the following. If you actually use that ticker that actually ticked at every 500 microsecond and you actually placed, so here's the timer and you actually do here and you place it after a T flip-flop. So I want you to imagine what will happen. We don't connect it to the T. Actually, what we do is we connect it to the T. Why not? So we're going to connect it to the T. Or maybe we'll connect it to the enable of the T flip-flop, not the T. So we're going to do this in here, and we're going to click, and we're going to see the T will toggle, okay, or something like that. It will enable, it will toggle every few nanoseconds. So if you actually connect it to the enable, this is how we generally use tickers and timers. If you connect it to the enable of a T flip-flop in here, well, this ticks every 500 microsecond. So at the very beginning, for example, it will last for 500 microsecond. At the output of that T will last for 500 microsecond. Okay, and then it ticks. So when this ticks in here, it enables it. Since the output is 1, it'll actually flip its output. So it will flip it and make it 0. And for how long will it last? Well, for till the next tick. So that's 500 microsecond. And what we have just done is we just created a clock generator for 1 millisecond or 1000 microsecond. Okay, so the timer we just constructed was parameterized. So you pass it as or you pass the time or the final value as a parameter. And once you create a digital system and you specify that parameter, that timer never changes and cannot be changed. That's it. But what if you want a timer that changes dynamically based on some sort of a user input or something else? So, well, you can actually use the modulus counters like we did with the modulus counter. We can actually pass the final value as an input. So what I have done in here is I actually created this particular timer here, and this particular timer, instead of passing everything as a parameter, what I did is I said, well, the final value will be passed as an input. That means this timer is dynamic and can change its ticker on the fly based on some sort of an external input. Again, it's the same as before. I basically went to the modulus counter, the input, I just copied it and I just changed it a little bit. I don't need the output queue. That's why I'm removing it from the output, but everything else stays almost exactly the same. Actually, it is the same, so I'm just putting the output as done. And then I created some sort of test bench just to show you, and I'm now running the test bench. So let's see what that test bench is in here. So the test bench now allows me to show you different final values. So you can see here I'm changing the final values. So let's see the final values in here, for example. So the final value, okay, in here I want it to be 255, and in here I changed it at some point and made it 4,999. So I'm going to stop at the done in here, okay, and I'm going to say, well, take me to the very beginning, okay, go to time 0, and then I'm going to say, when did it change? Well, it changed right here, so I'm going to add a marker, and then I'm going to do change, okay, and then I will add another marker in here, and then I'm going to click on it. I'm going to see how much is it. Well, let me just see. I think this has to do with the reset. The very first marker has to do with the reset. Let me just do that here. So, well, why don't I just remove this marker here? I'm going to just do that in here. And here, and I'm just going to move this up so you can see it. I don't believe we have that. Okay, so here's that marker in here. I'm going to create that here, and I'm going to say, well, why don't we go to done and then next marker and next marker and next marker, and now I'm going to add that marker in here. Now if I click on it, you're going to see the 2.56. So the ones at the beginning, there's like some sort of a reset or something, so that's probably why it detected the very first one. What I care about is it's actually ticking at exactly 2.56 microsecond, like what we calculated here on the slide, okay, because the final value is 255. So now what about if I actually go and say, all right, so well, I need the next, well, why don't I just do this here? and I'm actually at the enable, that's why it's doing that. So I have to highlight the done, and then I need to do this one, this one, this one, this one, and now the next iteration will be here. I'm just going to add a marker. So the one between this and the previous one is definitely not going to be something that I counted, because I changed the count on the fly. So if I click on it and I just say here, this is here, it actually did change it. Let me just see. This is actually 500 microsecond, because I guess I changed it at some point in there. Okay, but anyway, you get the idea. So the idea is I'm actually changing that on the fly. So I can just say this one here and this one here, and it lasts the last one in here. And if I calculate this here or stopped at that, it tells me that's 500 microsecond, exactly as I expected. So you can see all these markers and calculate the differences between them and see that. The point I'm trying to make in here is that in that particular test bench, what you will see in terms of timer is that I am changing the final value on the fly depending on an input from the user. That's how this particular test bench is written here. So you can see that I'm resetting for a short period of time and then not resetting, I'm enabling it, I'm making the final value 255, I'm waiting a little bit, I'm making the final value 4099, I'm waiting a little bit, and I'm seeing everything there.